Hey guys, it's Eleanor, and I'm doing my final project on the intersection of secants and circles, plus using tangents and basic algebra to solve for the lengths of them. Okay, so first off, what is it? Later on we'll be having some key definitions and ideas that will help better explain this idea, as well as some problems to help work through the process on how to do it. Alright, so some key ideas and words. A secant is a line that pierces the circle, or two chords that intersect outside the circle. A tangent is a line that touches a circle on one point and is perpendicular with a diameter of a circle. And a chord is a line segment whose endpoints both lie on the circle. Alright, so here's our first example. We have a circle, and it has two secants outside. So what we'd want to do is we'd want to make two triangles, as we can see by the dotted lines, and draw them on our page without changing them. This makes it easier to write a proportion, yay, because the two triangles are similar. Then we just cross multiply and then solve it like a basic algebraic equation. And then therefore we get x equals 17.25. As we can see, it's not a hard problem because there's only a few steps. As you can see, easiest. Alright, let's go to the next one. This one's going to be a medium problem, a little bit harder. Alright, so we have this problem, which has a tangent right here and two secants where we solve for x and we solve for y. Okay, so to find x, we want to draw our two triangles again from the two secants pointing outside, and we set up our proportion again like we did the last problem, and then by cross multiplying 5 plus x and 19 is 6, we get our equation. Again, we just subtract 25, get 5x equals 89, then get that x equals 17.8. Now to find y, what we do is we draw our two triangles from the tangent, which is, we draw this with where the dotted line is shown, and we draw a big triangle using 17.8 and 5, which equals 22.8. Then we set up our proportion, cross multiply, and then this time we can see that y times y equals y squared. We just square root it. Then we get y equals 10.68. This one's is a medium problem because there's a little bit more steps, and we have the y squared, which means we have to square root instead of just divide. Alright, let's go to the hardest one. Alright, so what we have here is we have two circles that share a tangent, some secants, and we have the lengths right here. This equals 12. Alright, so to find x, again, like the last few problems, we just draw our triangles, but this time we're going to draw our triangles with the little circle so we can find the length of x. So, x is 30. X and 30 is the first one. X and 42 is the second one because we're drawing our big triangle right here. And then we have x is to x as 42 is to 30. X squared, square root, x equals 35.496. This one isn't as hard because it's just setting up the proportions and doing the triangles. Now, this is a little bit bigger because we have this entire long piece and the tangent. So all we want to do is, again, set up our triangles, and we know that x equals 35.46, but 17, we want to do this entire one for this big triangle, so we know that's 17 plus y. And this one is just 17 and x, which we already have is 35.496. Set up our proportion again. 289 plus 17y equals 1,260. Subtract 289. 17y equals 971. Divide by 17. Y equals 57.12. This one's the hardest because it has the most steps, and so that's why it required a little bit more, and we also have that tangent in between the two circles. But really, this isn't a horrible problem. Alright, so why does this method work? This method works because every time we draw a triangle with our inside of our circles with the secants, they all make similar triangles. And so we can set up a proportion based off of those similar triangles. This method would not work if we were just setting up random things, because the similar triangles would not equal each other. Thanks for watching. Hopefully we learned a little bit more about the process that goes through the intersection of secants and circles.